Hello everyone. Yesterday I have discussed the concept of digraph. Hope it is clear for you. Let me revise the basic key points that we required. A digraph is said to be reflexive only when all the vertices has self-loop. Second one, a digraph is said to be symmetric only when all the vertices have bidirected edges. Bidirected edges. And coming to the concept of transitive, when we have an edge from V1 to V2, again when we have from V2 to V3 the common vertices, then there should be an edge between V1 and V3, then it is transitive. And when do we say it is antisymmetric? When there is no bidirectional edge. When there is no bidirectional edge, in such case it is antisymmetric. Now let us solve few problems based on the same concept. Go to the question. Here is a question. They had given you a set A which contains an elements A, B, C, D, and based on this set a relation is defined. Here relation is from set A to set A itself, and a relation consists of ordered pair of an elements AB, BB, BD, CD, C to B, D to A, D to C. Now the question is that we have to discuss the nature using the digraph. In the question only relation is given and original set is given. We have to draw the digraph first before discussing the nature. When you are going to draw digraph or matrices, even though using matrices also we can decide the nature, but in the question it is clearly mentioned we have to draw a digraph for this. Copy down this problem to the notes and just listen to me. Solve this. We have to solve this, right? First you just copy down the question. Now first listen to me how we are going to solve. Now look at the set A. How many elements we have? 4 elements. And in digraph those 4 elements represents vertices. Fine. A, B, C, D. Fine. 4 vertices I have marked. Now look at the relation. In relation, first element we have is A to B. Fine. In the sense we have to connect an edge from A to B. Let me do that. A to B. Direction is very important here. I have marked an edge from A to B. Next element we have is B to B. In the sense B to B represent a self loop. B to B. Next element B to D. B to D. I have marked an edge. Next element C to D. C to D. Look at the arrow direction. C to D. Next C to B. C to B. Next D to A. D I have here. D to A. Look at the arrow direction. D to A. Fine. Next D to C. D is here. D to C. Arrow mark. Fine. If you are finding, yeah, C to D already is there, and D to C I have marked an edge. Fine. Now let me discuss the nature of our relation. First one is reflexive. Fine. If you are finding confusion with this graph, in the representation of a arrow mark, you can clearly write this graph in another form, something like this. B to B an edge is there. You can write arrow mark here so that it looks good. D and arrow mark here, and I have a vertex C here. Like this you can write. Remember I have not mentioned arrow mark for this self loop. Only I have mentioned an arrow mark for B. It is clear that self loop is there only for vertex B but not for any of these 3 vertex. Fine. First let me talk about reflexive. When we say a graph is reflexive, only when all the vertices should have self loop, right? Do we have a self loop in all the vertices? No, we don't have. We have a self loop only for vertex B, but we don't have any self loop for remaining vertices. So I can write R is not reflexive. R is not reflexive. Next one is symmetric. Let me talk about symmetric. So as I already told you, when do we say it is symmetric? There should be bidirected edge for all the vertices. Do we have a bidirectional edge from A to B? We don't have. So one condition is more than enough to write it is not symmetric, right? Even though we have a bidirection edge from C to D and D to C, only one edge which is bidirected. Look at here. Bidirected, in both the directions we can go, but for rest of the vertices we don't have bidirected edges, so that is the reason or is not symmetric. Fine. Now let me talk about transitive. You can just look at the diagram. If you are finding confusion in the diagram, in the relation itself you can identify. See, A to B, an edge is there. Fine. And B is continuing here, so A to B obviously edge will be there. Check for the remaining pairs. Fine. Something like where we have a continuation like C here, CD and D to A, right? Meaning is I have an edge from C to D here, C to D. Again I have an edge from D to A. Fine. C to D, D to A. But do we have an edge from C to A? See here, we don't have an edge from C to A. C to A, edge is not there. Look at the diagram, just do the cross checking. C to D we should have. See here, C I have here, C to D I have an edge. Fine. Continuing with D to A. D is here, A. D to A I have an edge. But I don't have any edge between C and A. Right? So, transitive condition is fails here. So, it is not transitive. Since it doesn't have any self loop for all the vertices, so it is not reflexive. And moreover, there is no bidirectional edge between the vertices, so it is not symmetric. Now, transitive condition, since I have an edge between C to D and D to A, but I don't have an edge between C to A, so that is the reason it is not transitive. Fine. Now, coming to the antisymmetric concept. Antisymmetric. So, as I already told you, when we can say it is antisymmetric, only when there is no two edges which is having bidirectional edges, right? Or no bidirectional edge, we can remember like this, no bidirectional edges. Bidirectional edges. Do we have any bidirectional edge here? Yes, we have. See here, C to D I have an edge. Again D to C I have an edge. At least one pair is having bidirectional edge. But as per antisymmetric, there should not be any bidirectional edge. Then only it is antisymmetric. But you have a bidirectional edge here, so it is not an antisymmetric. Not an antisymmetric. Fine. Self loops, reflexive. All the bidirectional edges, symmetric. So here you don't have any for all the vertices you don't have a bidirectional edge, so it is not symmetric. Coming to the antisymmetric, since I have at least one bidirected edge, that is from C to D, so it is not an antisymmetric. If there is no direction between C to D, bidirection between C to D, then it will become an antisymmetric relation. Hope it is clear for you. Now let me solve one more problem so that you will understand clearly. Look at the question. Matrix is given in this case. Fine. Matrix is given to us. We have to construct a digraph. Remember, whether they'll give relation or they'll give matrices, we have to construct a digraph for that, and based on that digraph we have to discuss the nature of a relation. Now what we have a matrix, so give a number to that, 1 2 3 1 2 3 as I done earlier. So we have 3 number of vertices. Let me take the vertices as something like this. Vertex 1, vertex 2, vertex 3. Now, look at the matrix. Do we have a relation from 1 to 1? Yes, 1 to 1. So, I can mark self loop for 1. Why? Because 1 to 1 a relation is there. Next, 1 to 2, 0. Meaning is 1 to 2 there is no edge. There is no edge between 1 to 2. Next, 1 to 3. Since I have marked it as 1, so there exists an edge between 1 to 3. So, let me mark an edge which is directed from 1 to 3. Next, coming to the second row, do we have relation from 2 to 1? 2 to 1, 1 is there. So, there exists a relation from 2 to 1. So, 2 to 1, 2 to 1. Here, direction of arrow is very important, 2 to 1. Next, 2 to 2. Yes, there exists a relation from 2 to 2. So, I'll mark this. Self loop, 2 to 2. Next, 2 to 3, there is no edge. So, that is the reason I have marked it as 0. Next 3 to 1, 0. In the sense 3 to 1 there is no bidirectional edge. Again 3 to 2, 0. So there is no edge. Now 3 to 3, yeah, I have an edge. Andre self loop we have 3 to 3. Fine. So now talk about the nature of a relation: reflexive, symmetric, antisymmetric, and transitive. Reflexive, just by looking at the matrix we can decide it is reflexive, right? Why? Because look at the principal diagonal element, as I already told you, when all the principal diagonal element is 1, it is reflexive. Now look at the digraph, all the vertices has self loops, right? So when all the vertices has self loop, it is reflexive. Yes, it is reflexive. Fine. Next, coming to the concept of symmetric. So when do we say? When we have all bidirectional edge. Do we have any one of the bidirectional edge? We don't have, right? So it is not symmetric because there is no bidirectional edge. Now talk about the antisymmetric. Just now I have told you, if there is no bidirectional edge, at least one pair should not exist. So if there is no bidirectional edge at all, then it will be antisymmetric. So yes, it is antisymmetric. Suppose if there exists one bidirectional edge, then it will not become antisymmetric. Since there is no bidirectional edge, so it is antisymmetric. Next concept is transitiveness. Now check for the relation. So for the transitiveness, we can, just by looking at the matrix we cannot decide. Further we have particular condition to say given matrix is transitive. I'll do that in the later classes. Right now talk about the digraph. How can we decide a digraph is transitive? Look at the arrow diagram here. Digraph. I have a relation from 1, right? There should exist any common vertices. See, I have a direction from 2 to 1, right? Do we have 1 to 3? Yes, we have. See here, 2 to 1 there exists an edge. Again 1 to 3 there exists an edge. Then since it is common, there should exist an edge between 2 and 3, right? There should exist as per the definition of transitive. If it is common vertices, 2 to 1 edge is there, 1 to 3 edge is there. Then if it is transitive, then 2 to 3 should be there. But we don't have an edge between 2 and 3, so it is not transitive. It is not transitive. Is this clear? Hope it is clear for you. Now let me solve one more example. Now the same concept. Matrix is given to us and they asked us to draw the digraph and we have to discuss the nature of a relation. So the same procedure. Mark this as 1, 2, 3, 1, 2, 3. Now how many vertices we have? 1, 2, 3. I have marked 3 vertices. Now look at the relations. Do we have a relation from 1 to 1? Yeah. When I have 1, there exists a relation. When I have 0, there is no relation. So 1 to 1, there is a relation. So I'll mark self loop. 1 to 1. Next, 1 to 2. There is no relation, so I cannot draw an edge. Next, 1 to 3. There is no relation, so I cannot draw edge again. Now 2 to 1, 0. So 2 to 1 also there is no edge. Next 2 to 2, 1. So there exists a self loop for a vertex 2. Why? Because 2 to 2 there is a relation. Now 2 to 3 is 0. So 2 to 3 I cannot draw an edge. Fine. Next 2 to 1. 2 to 3 is finished, right? Now coming to the third row. 3 to 1. 3 to 1 there exists a edge. Why? Because I have written 1 here. So I have to draw an edge from 3 to 1. Not from 1 to 3. Remember 3 to 1 I have an edge. 3 to 1. So arrow mark is in this direction. Next 3 to 2. 3 to 2, 0. So I cannot draw an edge now. Again 3 to 3. So there is an edge. Let me mark a self loop. 3 to 3. This is what the digraph is. But the thing is it is disconnected graph. Right? Now talk about the nature of a relation. Reflexive. Is it reflexive? Obviously it is reflexive. Why? Because all the vertices has self loop. So it is reflexive. Now coming to the concept of symmetric. For symmetric, there should exist all bidirectional edge. There is no single edge, so we cannot talk about bidirectional edge, right? So it is not symmetric. Fine. Next, let me talk about antisymmetric. There should not be any, bidirectional edges. If there is no bidirectional edge, we can say antisymmetric, right? But in this case, there is no bidirectional edge, right? we don't have any edge from 1 to 2 and we don't have an edge from 3 to 2. No matter whether there is an edge or not, anyhow we don't have any bidirectional edge. So it is an antisymmetric relation. Fine. Now talk about transitive. Transitive. Is it transitive? No, there is no such pairs, right? To talk about a transitive, there should exist something like this, right? Common vertices edges should be exist. But in this diagram, we have 3 to 1. But there is no other edge to talk about transitiveness. So if that was the case, we cannot decide transitiveness. So it is not transitive as well. So this digraph is only reflexive and antisymmetric. I'll send the notes of this. You just understand the concept. Okay. Now, next question. Find the relation R and represent a digraph. Also write a matrix of relation. Let me write the problem. So problem given is, they had given one digraph, something like this. Let me write the digraph 3 to 4 and have a self loop for this. You have to take care of a direction of arrow mark. That is very important in digraph. Fine. Now I have something like this digraph, right? Now, how can we draw the graph here? Clearly, how many vertices do we have? 4 vertices. Now, for your reference, go to the question first. What we have to write is, we have to write the relation and just have to represent the same in matrix relation. In this case, no need to find the nature of a relation, right? Now, before writing the matrix of relation, first let me write a relation. So, how can I write the relation as? Just go through the edges connected. I have a relation, see the arrow mark, I have a relation from 1 to 2. So write down the ordered pair 1 to 2. Fine. Next, coming to the point 2, I have a self loop for 2. Why? Because I have mentioned an arrow mark. So it indicates self loop. So I can write 2, 2. Fine. Next, from 2, I have an edge from 2 to 3. So write down the ordered pair 2 to 3. Next, I have an edge for 4. Self loop. So I can write 4, 4. Again, I have an edge from 1 to 4. So I can write 1, 4. Now, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right? Now, do we have, suppose I have one more arrow mark, something like this. Now, we have to add that relation as well, like 4, 1. Why? Because 1, 4 is different from 4, 1. Now, I have written arrow mark here, so let me write 4, 1 here. So, this is what the relation is. Now, I am going to represent the same in matrix. How can I write? See, the first element is 1, 2, 4. I have. Anyhow, the 4 elements is there. Let me write 1, 2, 3, 4 here. Again, 1, 2, 3, 4. Just for your reference. Now, go to the relation. Do we have an element 1, 1? We don't have, so it is 0. Do we have an element 1, 2? Yes, we have, so make it as 1. Do we have an element 1, 3? No, we don't have, so make it as 0. Next, do we have an element 1, 4? Yes, we have, so make it as 1. Similarly, 2 to 1, there is no 2, 1, so 0. Next, 2, 2, yes, we have, so 1. Next, 2, 3, yes, we have, 1. 2, 4, no, we don't have, so it is 0. Next, 3, 1, we don't have in the relation, so 0. 3, 2, again 3, 2 is not there, so make it as 0. 3, 3, again 3, 3 is not there, 0. Why? Because for 3 to 3, I have not drawn any direction or arrow mark for 1 and 3, so there is no self loop. 3 to 4, no, so 0. Again 4 to 1, yes it is, so let me mark it as 1. Next 4 to 2, there is no edge, make it as 0. Next 4, 3, no, 0. Next 4, 4, yes I have, so it is 1. So given a digraph, we can write it in matrix form and similarly we can write the relation for the same. Hope it is clear for you.